Okay guys, we're back. So as you can see, it's 12 p.m. and I can't believe it actually took 2 hours to render and upload a 1-hour video. And I know right now you can't hear the me typing on the keyboard. Well, I'll tell you what happened. What happened was I actually recorded this video and did an entire 1 hour and 30-minute narration and you know recording, and it turns out that I was not recording audio. And oh my goodness, I found out after the recording, an hour and 20 minutes later of this video, I found out that I was not recording. So now I'm in here watching this video, recording everything over again. My stupidity. Anyways, I'm gonna try and narrate as I go through this video one more time. Oh my goodness, I can't believe this. Anyways, what I'm doing right now is I guess what I did was I took the liberty of downloading the main character sprite sheet that we're gonna be using for our game, and it's by Dog Chicken. I can't believe it. I said the same thing an hour and 20 minutes ago. Now I'm saying it again because of one simple button that I forgot to hit before the recording began. Oh man, I can't believe this. That's why you're not hearing any clicks or any keyboard typing like that. That's why. Anyways, I'm gonna stop whining and I'm just gonna sit down here for an hour and 20 minutes narrating everything that I've done. It's very frustrating and it's very disheartening, but I guess I'll do it again. Alright, so what I'm doing here now is I'm showing you guys that what we're gonna do with this sprite sheet is we're gonna split it into pieces. And what I'm showing you guys right now is that if we look at the sample concept art and we copy and paste the main character, the sprite over there, we see that it's actually about twice as big as the sprite sheet that we downloaded. So what we're gonna do is we're gonna scale the image of this sprite sheet that we downloaded 200%. Right, double it, scale it twice, the width and the height. And at this point I actually made a mistake in the scaling. You have to choose no interpolation when scaling sprites like this, because interpolation blurs the image. We don't want the image being blurred, so we don't want to. So whenever we're scaling images like this, we want to use no interpolation. And here I made a mistake of I scaled the image but to its original size. You know what? Let me just pause the video right here, and I'm gonna continue narrating over this again. Just get some water. I just can't believe it. Alright, so what I'm doing here is we're going to take this sprite sheet and cut it up into pieces. What I'm going to do is just control copy and paste into a new window. And what I'm going to name this, I'm going to name this Nekko idle 0.png. So Nekko, oh, I guess Nekko walk 0.png. No, that's supposed to be idle. I made a mistake here. Yeah, but it's supposed to be idle. I just made a little mistake here. So that was Nekko idle 0. This is Nekko idle 1. And you're gonna see why I'm naming it like this, because we're gonna be putting these sprites into a texture atlas. So this should be Nekko walk, I guess. Nekko walk 1. I'm so retarded. It's supposed to be Nekko idle, anyways. So I'm just explaining how we're gonna take this and each sprite and put it into a one folder, and then I realized that, oh, it was Nekko idle all along, not the walk animation. So that is the sprite sheet, again by Dog Chicken. And I'm saying that during the 2-hour break that the video was rendering and uploading to YouTube, I took the liberty to do what I just did for the idle loop and do the same thing for the rest of them. So I named the walk loop Nekko walk 0, Nekko walk 1, Nekko walk 2, Nekko walk 3.png. You get the point. So that's what I'm doing right now. That's what I'm explaining. So Nekko walk 2, 3, Nekko walk 4, Nekko walk blah blah blah. Nekko jump 0, Nekko jump 1, and that's just the way I name things, because this is going to be fed into the texture packer, which is going to create, before I talk about that, here I talk about how I added one frame. I added one frame to the end of this. So instead of the frame, the downward kick frame, downward kick animation loop ending right here, I just copied one more frame over there. And I did that for this frame. So these 3 frames that I just pointed to, the 2-sided attack frame, animation loop, the round kick animation loop, just to smoothen things out. So I just added one frame. I'm going to put that in the comments in the code once we actually start using this. And I guess I also forgot to mention that whenever you're cutting, splitting those into pieces, make sure that you're saving them in the same dimension and they're properly aligned. Otherwise, they're going to be jittery. And now I'm explaining how I put them in the same folder. As you can see, Nekko dead 0, Nekko dead, and this just represents the animation frames for each animation loop that we're going to be using. So we put them all in the same folder so that the texture atlas, the texture packer GUI that we're going to be using, will be able to pack these up into one texture. Now I'm explaining that I cut up the background. Instead of the width being 900, I cut it up so that it's only 600 to save some space. And now I'm explaining that I also took the liberty to do the same thing that I did for those sprites. I do the same thing for the HUD. So I took that, so that's the top left, top right.png, top left.png, top right.png, dpad.png, options.png, start.png, that's the attack.png, and that's the jump.png. And I put them all in this folder. Oh, and you know what, guys? You know what I'm going to do? Since you can't hear the keyboard being typed, I'm just going to add some background music to this, because I know it's kind of dull just listening to my voice without some ambience, like, you know, the keyboard being typed, the mouse clicks. I know it's pretty boring. So I'm probably going to add like a background music to this video, just to this video. The next video, probably not. Hopefully I won't mess up like this again. God, now I'm explaining how I did the same thing for the tile set that we're going to be using to generate the maps. So I named them piece 0, piece 1, piece 2, piece 3, etc. And I'm going to show you where I got those textures, those tile sets. No, it's not over there. It's right over there. And what we're going to do is we're going to download the PSD, not the PNG, but the .psd file. And the nice thing about GIMP is it also supports .psd file, so it's really pretty cool. I mean, for a free software, GIMP is overpowered. It's really great. I love GIMP. So now I'm going to edit this with GIMP. And we're also going to scale the image by 200%. It's like what we did with the previous ones. Make sure that interpolation is none. And here I just show that I just did the same thing. I copied and pasted this piece in a new window and saved it as piece 0. Now I'm having some trouble because that window was open. Let me close it. Sometimes this happens with GIMP. I'm just trying to copy this into a new window, but it turns out I'm in the wrong layer and stuff like that. Anyways, noob mistake. So the way I'm going to name this, I'm going to name this piece 0, just like what I named it in this folder right there. Piece 0, piece 1, piece 2. And then those are the plants, steps, and so those are the map pieces that we're going to be using. And I explained how I cut up piece 12 and piece 13. If you put them together, it's actually just piece 9. And piece 2, we cut it up into piece 10 and piece 11. And I'm going to show you why we did that later on. You're going to see why we're doing what we're doing right now. But for now, just bear with me. It will all make sense soon enough. You know what? For this mistake that I did, I am going to punish myself. Now I'm just talking about how I cut it into half. I mean, it's pretty self-explanatory. But as I was saying, because of this frustrating mistake that I did of not recording the audio while recording this video, and now I'm in here watching this video on my video recording software, which is Camtasia. I am not going to sleep tonight, okay? Because I deserve punishment for being stupid. So, if this happens again, I don't know what I'm going to do. I'm probably just going to stop. I'm just delete everything about this project. I don't care anymore. Like, seriously. Horrible. Anyways, yeah, just have the put everything in this folder. Put all the resources, well, most of the resources that we're going to need for the next couple of videos in this folder. And what we're going to do is we'll just pack them up in a texture atlas. I think that's what I'm saying here. Yeah, I'm talking about how you're supposed to align them, otherwise they're gonna be jittery. What happened? Okay, what happened? It suddenly froze. Did it freeze? No. Vandolph, move! What are you doing? Oh, what are you doing, Vandolph? Did it really freeze? Did the recording really freeze? Are you kidding me? No, maybe it's just a bug. Let me just... Okay, it's still not recording. It's still not moving. Okay, there it is. I guess I was talking a lot. Oh yeah, no. I guess I was talking about how the Texture Atlas class of LibGDX was going to use this. So yeah, the Texture Atlas class of LibGDX we're gonna pack them up into a Texture Atlas using. So we're gonna download the Texture Packer Gui in order to pack those up. And what I'm doing here is deleting the history because I was afraid that you guys are gonna see some web pages that you're not supposed to see. Anyways, I was saying that you can download it in the wiki, the texture packer, or you can also download it in the downloads. Anyway, we're going to download it, the texture packer GUI, in the wiki. And where you're going to find this in the wiki is Tools, Texture Packer. And what we want to do is download the texture packer GUI. And for some reason, when I clicked texture packer 2, it led to a page not found for some reason. Then yeah, I was saying that we want to pack everything in a texture atlas because texture switching, binding the texture and then texture switching, is relatively expensive. It can make the difference between 70 frames per second and 20 frames per second. So that's a huge difference, right? So now we're going to download the texture packer GUI. And I talk about how the texture atlas. I just describe it in brief. How the texture packer is going to pack all of those things in the folder and then write the necessary information in a .pack file that the texture packer, the texture atlas class of LibGDX, is going to use in order to parse. So the texture packer, the texture atlas class is going to parse that information in the saved in the .pack file, so that we can use it. We can use the individual sprites that we saved in that texture atlas. And again, we're doing this. So this is the texture packer GUI by Aurelien Ribbon. Thank you for him or her, or him or both. Him and her is what I meant. I really love this GUI. It's really good. It's really nice. I've been using it for my other project, Heroes of a Lost World, simply because I don't want to use it the packing on at runtime. It's kind of slow, having to repack everything. So he's going to download the zip. Oh man, I can't believe it. I'm watching this over again. I still have an hour to go. I still have 1 hour to go of narrating the video that I just made. I'm sorry guys, I said I was going to stop complaining and whining. I feel like crying though. Anyways, we're going to open it up, we're going to run it. And what we're going to do is we're going to create a new pack. Now remember when we said that in our program we named it, we're going to put it in a folder called texture, and we're going to name it KungFu Nekko.pack. So we're going to name this KungFu Nekko. And make sure you don't change these values. These are very important. Now if you want lower color values, you want RGBA 4444. If you don't want any alpha, this blending is disabled, you choose the one with RGB with no A. And make sure the min and mag filter is the minification filter and magnification filter is nearest to nearest, because our game is a 2D platformer game. I don't think we need any interpolation whenever magnifying anything. As a matter of fact, it looks best without interpolation, because with interpolation most of the time it's going to be blurry. And it's a natural thing to do, our eyes blur things. Anyways, so we're going to select the folder in which we have all those images, and then we're going to select our destination where where the output is going to be written to. And that was really fast. I talk about how fast it was. So yeah, now we have all the sprites in one texture, in one PNG image of size 1048 by 1048. It's 1048, it's a power of 2, but I don't think it's necessary. But for older versions of OpenGL, powers of 2 was mandatory, but I guess for newer versions it's not. I don't know about OpenGL ES 2.0 though. It seems that the texture packer forces me to use powers of 2 dimensions. I think, I mean, from my experience. Sorry about that. Now we see that the texture packer GUI outputted KungFu Nekko.pack, which is just a text file that has, you know, the names of our PNG images that we packed and some extra information. For example, rotate. Is it rotated? What's the X and Y value in the image? What is the size of the texture? Stuff like that. Now, if we open this, we're going to see that the X and Y coordinate corresponds to the coordinates of this texture where Y grows downwards. So if we take a look at piece 1, which should be at X equal to 1 and Y equal to 701, piece 1 should be I'm pretty sure I point to it right there. Piece 1 should be that texture right over there. No, not that one. I said not that one. I said not that one. Vandolph, you are stupid. Vandolph, you are so stupid. I hate your guts. Yes, that one. But it doesn't start over there. It actually Y grows downwards, so if we take a look at the background texture, let's just find it. Okay, the background is at X is equal to 1 and Y equal to 767. So that's the background right there. The big rectangle with a purple and orange. Should be 1 and 767. I'm just showing you guys that what the texture atlas class is all about and what the texture packer did. It's just, you know, wrote a text file so that the texture atlas class can parse the PNG image texture that it packed the sprites into. So now I'm explaining how that's actually the start of the point. That's the point that the texture atlas records because Y grows downwards. So that's X equals 1 and Y equals 767, and then Y grows downwards. So it's actually storing the images upside down, I think. Now I'm saying that we're gonna have access to these individual sprites via the texture atlas class, and you're gonna see how we're gonna access these sprites. And now I'm explaining that in OpenGL, textures are from 0, texture coordinates are float values from 0 to 1.0, and how you're going to have to, in order to get the corresponding texture coordinate of this value, you're going to have to do some ratio. So for example, our width, the texture width is 1024. So what we're going to need to do is map 1024 to a float value that is between 0 and a 1. So x equal to 1, translate that into a float value from the range of 0 to 1. That's going to be 1 over 1024. So that float value is going to be the texture coordinate that we're going to pass in GLTeX coord 2F or whatever. Yeah, I guess that's what I'm explaining in this here. And I'm still trying to explain OpenGL, which I'm not even good at. I like doing that, you know, explaining things and I'm not even good at it. Anyways, I can't help but crying. This is not gonna happen again. But hey, good news! There's gonna be background music here. Okay, now I'm talking about how we're going to create a texture folder, and we're going to put the KungFu.Nekko.pack in the texture folder in the Android project. Now, yeah, all the assets are going to be accessed from the Android project's assets folder, as you can see right over there. So we're going to create a folder, texture, and we're going to put the PNG image and the pack file that the texture Packer Gui made for us in the textures folder in the Android project right over there. And I also took the liberty to get started on the attribution file. Now, this is the format that I write the attribution text file to, because this is very important. You guys can get in trouble if you don't include this. Always include where you got your resources from. Even if they're CC0, include them anyways, because you're going to need them sooner or later for reference. And how even if your game is commercial or non-commercial or whatever, just keep track of the resources that you're using. Now, you usually want to record the name of the author, the license under which it was given, the title of the work, and the link. So, for example, the sprite sheet that we downloaded, which is not here, this is actually missing one, which is the sprite sheet, the main hero, the main character sprite sheet. I forgot to put it up there, but I guess I'll put it up there later. I'm talking about the title, by the way. And now I'm talking about how we're going to use some of Red Shrike's work, the effects from the USF sprite sheets. We're going to use them later on, but for now we're just going to put it here just as a reminder that, hey, we're going to use Red Shrike's sprite sheets somehow. If you guys don't know Red Shrike, he's a BAMF, he's a boss, he's, a guy at Open Game Art. He's a pretty cool guy. Awesome art. Awesome art. Anyways. Now I'm talking about whenever we add something to our assets folder, or really anything that we don't do in via Eclipse, we want to clean the project first so Eclipse can detect the changes. Because if we don't clean it, Eclipse will not detect that, hey, we added something new in the assets folder. So we want to clean it first. And now we can now draw stuff because we now have a texture to work with. And yeah, we're going to switch on the view. In case we're in the view loading phase, we're just going to update and render whatever loading that we have to do, you know, the loading screen and stuff like that. But for now, we're not going to worry about that. We're going to skip that for now, and we're going to go straight to the game. We're gonna do the loading later. That's not really top priority right now. So we're gonna go to View Game. And I know it sounds really boring right now with the keyboard typing. I know you guys like that. I'll just make sure that this never happens again. Oh my god, just because of... Okay, I gotta stop whining. Vandolph, stop whining. Anyway, okay. We're in our view game. What we're going to do is we're going to update all of our game objects. And the way we're going to do that is the following. Yeah, and I talk about how you want to put a maximum on the updates per second. Now, the updates per second should be separated from the frames per second, because check this out. If you're updating, if you don't put a cap, if you don't put a maximum on how many updates per second the game will be able to execute, then there will be an imbalance for different devices. What's going to happen is, if the device is faster, then the game speed will be faster. if the device is slower, then the game speed will be slower. So we don't want that. We want uniform game speed. And all we're going to do is put a cap on the updates per second. So what we're going to do is going to declare two constants. We're going to say long updates per second, UPS. We're going to say 50 updates per second. We're going to say 50 updates per second, final long, and then we're going to say the update interval. And I named the update interval, I just named it update time. How many, you know, what is the, how many updates are we going to be doing in 1 second? 50. So, and we're going to be working in nanoseconds. So 1 second is 1 billion nanoseconds. 10 to the negative 9. So that's actually 9 zeros over there. So the update time is just 1 second in nanoseconds over the updates per second, which is 50. And then it's going to need some variables. I mean, this is pretty self-explanatory. Last update time. And what we're about to do here, this thing that we're about to do. Oh, and I talk about how time utils, not nanotime, a libGDX function, is nothing but system.nanotime, which is a Java function, a Java library function. And I talk about how even though that's all it is, you still want to use the libGDX function time utils.nanotime, even though all it is that. It just returns system.nanotime. So you must be asking yourself, well, why not just call system.nanotime? Because maybe in the future, the guys at libGDX, the developers of libGDX, might do something different. They might change it. I doubt it, but they might change it. And if they change it, then you know, we're gonna have to go back to our code and maybe change a couple of things. So we don't want that. We want to use as many libGDX classes as possible instead of regular classes. And what we're doing here is pretty standard. At least it is my way of doing things. You know, you got your I mean, this is how I think it's pretty standard. I really don't look at other people's source code. I never looked at other people's source code except for that, with the exception of that simple game that in the libGDX wiki website. Other than that, I really didn't look at any other people's source code. You know, and maybe Code Geeks, I looked at some of their tutorials. But anyways, I'm explaining how this is pretty self-explanatory and how we're gonna only update after a certain amount of time. We're only gonna update our game objects after update time has passed. After, you know, 1 second over 50 has passed in nanoseconds. And then, you know, we set our last update time utils.nanotime. It's pretty self-explanatory. And now we're gonna check our heap. Now this is very important because garbage collection can slow the game down tremendously from 60 frames per second down to 0 frames per second. And I'm not even kidding, I have a lot of experience. Wow, what am I going to say? I have a lot of experience with this, but I have my fair share of heap experience. So yeah, FPS, the way we're going to do this is if the frames per second ever drops below 27 frames per second after 30 seconds from the last call to system.gc, which is garbage collect, we will then again attempt to garbage collect, call system.gc again. So what we're going to do is we're basically we're basically going to call system.gc every 30 seconds if the FPS is below 27. Why below 27? Well, basically sometimes the garbage collector doesn't garbage collect for us, and that drops the frame rate really below the 30s. So that's the way we're going to detect, well, it's time to garbage collect. And we don't want to be garbage collecting every 30 seconds unconditionally. So we want to put a condition there. So if it drops below 27, I think it's time to garbage collect. And what we're doing here is we're doing the exactly what we just said. So the way we're going to get the frames per second is gdx.graphics.get frames per second. If it's less than 27 and the time equals .nanotime minus last GC time is greater than 30 seconds, we're going to garbage collect. And of course, we're going to reset the counter, the last GC time, which we haven't created yet. Alright, that was the update heap. Okay guys, you are not going to believe this. You are not going to believe what I just did. What I just did was I was narrating my video for 30 more minutes, and it turns out that I wasn't recording my voice again. So I need to start again at this point narrating everything that I just narrated on. I'm really getting sick of myself. Okay. Oh my god. Alright, let me sorry about that big sigh. Alright, I have to say everything that I said again for the last 30 minutes. Alright. I am crying right now. I am crying right now. Like, you should see me. I am literally crying right now because of all of this stupidity that I'm going through. I'm recording, right? Okay, I am recording now. I am recording because the status says recording audio. Okay, I am now recording audio. And I'm sorry if I sound frustrated. Is it? Oh my God. Alright. Calm down, Vandolph. Calm down, Vandolph. You are retarded. You are the worst person in the world. You don't deserve to live. Anyways, what we're doing here is we're gonna start to make use of the interface that we created. Remember, we created an updatable interface, created a drawable interface, and we're gonna use LibGDX's disposable interface. And we're doing this so that we can put different classes in the same list so that we can avoid having to write a lot of lines of code. So we can minimize the amount of lines of code that we're going to write. And I'm going to show you how we're going to do that. So we're going to initialize our updatable array. And then in this array, we're going to add our updatable objects. Remember the objects that the classes, for example, map. Remember that if you go to our map class, it actually implements the updatable interface. And this is, pretty standard stuff. I'm pretty sure you guys already know this about how Java does not support multiple inheritance, meaning you cannot extend more than one class, meaning you cannot subclass more than one class. So the general rule of thumb is that if your class does not need to inherit or extend a class, then have it implement that class instead. This way you have more flexibility, because again, you can implement as many classes, as many interfaces as you want, but you can only extend one class. Only subclass or extend one class if it is so essentially necessary. Now we're adding drawable objects in our drawables list, and you're going to see why we're doing this. Okay, you know what? I am so upset that I am gonna call Chinese food and have them deliver me something, because I'm pretty upset right now. I'm gonna get fat like this. I'm gonna lose my six-pack that I worked so hard on. Well, I can always get it back. Once I get it, I can always get it back. Anyways, yeah, so now we added everything in the proper list. We have our updatable list, drawables list, disposables list. And now inside our update block, we're going to iterate through all of our updatable objects. And all we're going to do here is basically call the object's update method. I mean, because that's all the updatable has. That's all the updatable interface has, an update method. So that's all we can call. So for each updatable object in the list, we're going to call its update method. So what this is going to do is call the camera's update method, then call the map.update, then call the background.update. But I'm pretty sure you guys know this already. It's pretty simple stuff. Now I'm going to talk about how you can. There are different ways in iterating. Let me say that again. There are different ways in iterating through a loop. You can use this method right here, the second for loop, in which you create an abstract iterator that iterates through all of the updatable objects in the updatables list. So again, the two different methods, the two different for loops does the exact same thing. Now I prefer to do it with the integer equals 0 thing. With the integer equal to 0 thing because from my experience, I believe that creating an abstract iterator allocates new space in the heap, which creates garbage, and the more garbage, the more the garbage collection will be called. The more the garbage collection will be called, the slower your game will be. So you want to avoid having to allocate new objects in the heap once you finish loading the game in the loading phase. Alright, and now I'm showing you guys another way of iterating through that, which is declaring an iterator of type updatable, and then getting the iterator from the updatables list like that, and then checking if the iterator has next, if it has more objects, it's gonna iter.next, meaning get the next object. And then we now have the next object, so we're going to call its update method. And now I talk about the iterator class of LibGDX, how it's better than the java.utils iterator class. Let's get more information, look at the documentation. Now, I prefer to use the integer method for iterating through a list. Simply because, from my experience, and I don't know if this is true or not, from my experience, the other two methods, the while loop using the iterator and the for loop using the abstract iterator, creates, or rather allocates new space in the heap. As you can see there, iterator equals new iterator. But I guess it's not really true for this case because it only creates a new iterator object if iterator is null. So only creates it once. But yeah, I don't know, it might just be my preference to use the integer method for looping through things, but that's the way I'm going to be doing things. And I'm just telling you guys this now because I don't want you to think that, oh, he doesn't know how to use iterators. What a guy. He's making these videos and he doesn't even know how to use iterators. No, that's not the case. I just prefer it that way. Again, because because maybe the other two ways of doing. I mean, they do the exact same thing. However, efficiency-wise, they might be different, especially with heap allocation. I don't know. That might just be a superstition of mine. There might be the other two might not even be allocating new stuff on the heap. Anyways, it's my preference. I'll do whatever I want. Now let's delete that, and now I'm going to show you guys the views that the tools that you can use for the debugging the Android. And so go to a window, show view, other, and then go to Android, and then you'll see all the stuff that you should be using. Now, the logcat you should be familiar with, obviously. And now there's the heap and the allocation tracker. Now, you're going to need to get familiar with these two because it is very important that you keep track of where you're allocating new objects, where you're allocating new space for new objects in the heap. Because everything is dynamically allocated in the heap in Java. Do not quote me on that. I might just be talking out of my ass. I don't know. So yeah, so what I'm saying here is that avoid creating new objects, because if you create new objects, you're gonna need to allocate space for that object in the heap. And if you do that, at a certain point, you're not going to be referencing this object anymore, and then the garbage collector will be system.gc will be invoked, and system.gc is a pretty expensive operation, so you want to avoid that as much as possible. So what you want to do is load everything in the loading phase. Avoid creating new objects after the loading phase. Again, if you can load everything in the loading phase, in the case view loading, do so. Avoid creating new objects. So if you see a new keyword, the keyword new, N-E-W, anywhere other than your loading phase block, then try to change it. Hold on, guys. Let me just call Chinese food before they close. Okay. I just noticed that my voice is cracking, and I do apologize for that because I've been talking non-stop for the past 3 hours. Well, it's my fault. It should have only been for the past 1 hour and 20 minutes, but me being stupid, that's what happens. If you're Vandolph Estrelado, this will happen to you. So what's the lesson? Do not be Vandolph Estrelado, and do not name your kid Vandolph Estrelado, otherwise he or she is going to turn out like me, and you don't want that. Anyways, so frustrated. Anyways, now we're ready to draw some stuff on the screen. So yeah, before we draw everything, we need to set the projection matrix of our sprite batch to camera.combine. And don't get confused, guys. The camera, it's camera.camera, because remember, camera, we create a camera class, and inside that camera class that we created, we have an orthographic camera in which we called camera. So we're actually referring to the orthographic camera class's combined projection matrix. So that's why it's camera.camera.combined. I don't know what I'm saying here. I have no idea what. Oh yeah, I'm saying that we're not going to be putting our draw calls inside the update block, because again we want to separate updates per second to frames per second. So oh yeah, I guess I already spoke about that. Now what we're going to do is we're going to declare two colors, world color and target world color. Color is just a LibGDX class. It has four variables, R, G, B, A. And what we're going to do is we don't want to draw everything at full color all the time. So what we're going to do is we're going to draw everything at maybe say 70% of the color, because we're not going to be using OpenGL lighting. We're not going to be using lighting, so we're going to try and have some variation in the color. You know how so we're going to create a new color, 0.7, 0.7, blah, blah, blah. But as I was saying, you know how what do you call it? How things like flash, like things get brighter and then darker. So we're gonna create some leeway for us, so we're not gonna draw everything at full color all the time. So we have some room to increase the brightness. That's what I'm trying to say. That's all we're doing with this world color and target world color. And yeah, so we're just gonna set the color speed, which is the amount of color that we're going to be adding and decrementing for each color value, R, G, and B, in the update block. And you'll see what I mean by this soon enough. So yeah, we're going to just put this inside our update block, call update world color. Have Eclipse create the method for us. And all we're going to do here is make sure that the world color is equal to the target world color. So if the world color is not equal to the target world color, as a matter of fact, if the world color is greater than the target world color, we're going to subtract an amount color speed to world color to each of its components, except the alpha, until it is equal to or less than target world color. Because again, it's our target world color. That's why we named it that way. So yeah, if our target world color is .r component is greater than the target world color's .r component, the red component, all we're going to do is subtract color speed, an amount color speed to that component. Now if once we subtract that and our world color ends up being less than our target world color .r, we're going to set our world color .r equal to target world color, so that it doesn't need to go into the if statement again. And now what we're going to do is we're going to combine this if statements. First of all, what we're going to do is we're going to put this inside this if statement, because we can. So less lines of code. Minus equals color speed in parens. Now we can delete the above line of code. And we can also do another thing. We can combine the two if statements and make it into one. So just copy and paste this thing inside this if statement and end it, logical end, not bitwise, and end, ampersand, ampersand, that. And now we just reduce the amount of lines of code. Pretty cool. I mean, I'm pretty sure you guys already knew this, but you know, I'm just saying. And you can choose to do it this way, you don't have to. But it just looks prettier and more compact and neat. Now again, if you guys don't know this already, if the first condition, worldColor.r, is greater than target worldColor.r is not satisfied, meaning it will return true, the rest of the conditions will not even be checked. The Java compiler will skip those because, well, it's an AND logical operator, meaning that if one of its components is false, there's no point in checking the rest because all of it will be false anyways. So we're just going to do the same thing for the G and B component of color. We're not going to touch the alpha. Alpha will always be 1, which is fully opaque. And now we're going to do this. I'm just showing you a trick you can do in Eclipse. Just find R, make sure that it's case sensitive and it's whole word, and you can just replace all the instances of the word R with whatever you want. So there you go. Now we're checking for each component, the R, G, and B. And now we're going to begin the sprite batch. You need to call this every time you begin drawing stuff. And now I'm just showing you guys just how many lines of code that you're not writing, because everything is in this batch.begin method call. And you know, that's why I love the Sprite Batch class. It's really awesome. It provides you with a default matrix, default shader programs you don't have to deal with. So again, we're just going to iterate through each of our drawable objects in our drawables list and just call the draw method on each of them. And then once we're done drawing, make sure we call batch.end. Just basically wraps everything up, closes texture, disables texture, whatever. You know, all the routine pop matrix and whatever that you have to do with OpenGL 3.0 and above. Oh, for the Android, OpenGL ES 2.0. Anyways. Yeah, we're getting a null pointer exception, and it's because I did not initialize something. And I did not initialize the batch. Vandolph, pay attention. Vandolph, pay attention. You did not, yes, you did initialize the camera, but you also did not initialize the batch, the sprite batch. Now I'm going to get another exception. Vandolph, you are so stupid. Oh my god, Vandolph, if I can punch you in the face, I will. Oh, Vandolph, look at you, you're so dumb. Vandolph, I'm telling you guys now, do not name your kid Vandolph. Oh, I'm sorry guys, if your name is Vandolph, or you know a person named Vandolph, I don't mean to offend that person. I'm just trying to make fun of myself, okay? So I guess I'm being careless. I'm sorry if I offended anybody. I'm talking about myself, by the way. Right? Just wanted to let you know that. Okay, so now I figured it out after 10 hours. Just kidding, after 30 seconds, I figured it out. I figured out that, well, I did not initialize the sprite batch. That's why we're getting a null pointer exception. And now we can see that we're drawing the background. Not at full color, but at 70% color. And we're drawing it over there. Which is fine, because we're going to be drawing black edges over there. We're going to fill it with black soon. Yeah, let's try, maybe that's a little too much. The offset, the Y offset, let's try 0.1. That's a little too little. No, let's change it back. Vandolph, change it back to 0.2. Now. Vandolph. What are you doing, Vandolph? Vandolph, change it back to 0.2. I'm gonna kick this guy's ass. What am I doing? Yeah, anyways, I think that this is gonna be it for tonight because it's already 11:08 p.m. I mean, this should have been up in YouTube by now, and I should have been recording another one. But again, you know the situation. I wasn't recording my microphone, and I had to narrate. And even then, anyways, yeah. Did I change it back? No, I didn't change it back. Anyways, I think I'll change it back to 0.2. No, I didn't change it back. I guess it'll stay 0.1. Let's keep it that way. And then we're gonna initialize our HUD. I don't know why I put it there. Init vars. I'm probably gonna put it on the create. Yeah, I'm gonna move that on create on the next video. I don't think it belongs there. Yeah, so initialize our HUD, declare our HUD object. And we're going to create a new package. We're going to call it UI package. And we're going to create the HUD. Now the HUD is going to implement the updatable interface, drawable interface, and the disposable interface. And again, make sure you're importing the correct things. And what I'm going to do is I'm just going to rearrange this because I'm OCD a little bit. Public constructor, default public constructor. Oh, my voice is going to be sore tomorrow. Yeah, I'm gonna need to stop this for tonight. Could have done 3, but no. Anyways, yeah, so what we're gonna do in this HUD is we're gonna draw a filled rectangle. We're gonna draw 2 filled rectangles, one at the bottom, right here, and another one at the top. Right? That's gonna be filled rectangles. And then we're gonna draw a circle over there, and another filled circle over there. Yeah. So we need to draw 2 rectangles at the proper places and 3 circles at the proper places. And what we're going to be using is the shape renderer class, which is a pretty cool class. You can do you can draw a couple of things with it. You can draw circles, rectangles, filled circles and filled rectangles, triangles, lines, points. Basically, pretty much all the standard stuff that you can draw. So let's import the shape renderer. This is a LibGDX class. It's one of my favorites. Again, it abstracts. It prevents you from, lets you not have to call OpenGL calls to GL begin, GL lines, and all that stuff. GL polygon. And before we forget, let's make sure that it's the dispose. We dispose the shape when we need to dispose it. And all we're going to do, again, since this is a, we need to set the projection matrix to our camera's camera.combined projection matrix. And yeah, we're gonna set the color to black because, well, we want to fill everything with black. Then begin filled rectangles. This is like the Sprite batch class. So and then we're going to draw the bottom cover and the top cover. Well, first let's draw the bottom cover, which again is going to be at the left side of the screen of our device coordinate of our screen. It's going to be yeah, so here I'm talking about how there are other projection matrices, how you can use the projection matrix so you don't have to always you don't have to keep track of the rectangle of the camera. So instead of camera.rect.x, you can just say 0 for the leftmost side. But in the case of the projection matrix, camera.projection, it's going to be camera, the orthographic camera, dot x minus half of the viewport width. But we're not going to worry about that. We're going to keep things simple and coherent. So we're going to be using only one matrix, and that is going to be the combined projection matrix. Which basically sets everything with respect to the world coordinates, so it's pretty cool. So yeah, now we have a filled rectangle. And we're not going to draw this, and it's only going to have about 21% height. That's what it means. That's why I'm multiplying it right over there. There's a Vandolph, there's a parentheses, there's an open parentheses to your right, Vandolph. Jeez, look at you, Vandolph, look at you. There you go, there you go, good job. And now because we don't want to multiply this every time the draw method is called, let's just say bottom cover offset, or height, I mean. Finally almost done, just 10 more minutes of narration. I can... Okay. Okay. Now the following is just pretty self-explanatory. We're going to again draw the top corner, the top cover at the leftmost side of our screen, and at a height of so camera.rect.y, which is the bottom of our screen, plus the height of our screen of the camera. But we're not going to start there. We're going to start at 0.9, at 90% height, starting from the bottom of our screen. And the width is going to have the camera's width. It's going to fill the entire width. And yeah, so now and it's only going to have a height of 0.1 because it doesn't really matter. It can have a height of infinity if you want, since it's being drawn at the top. It's going to get clipped out anyways. So yeah, now I'm explaining that the way we're doing things is that's no matter where you are in the world, no matter what coordinates, since we're always updating our camera's rectangle that we declared, the bottom left of the screen is always going to be referenced as camera.rect.x, and the y coordinate of that, starting from the bottom left of our screen, is camera.rect.y. Now explaining how justifying the values that I put in for the for here. Now what we're going to do is we're going to we're going to draw the circles, but first we need to, before we can draw circles, we need to end the batch, because we're not drawing circles anymore. We need to send the we're not drawing circles anymore, so we're going to draw. And then we're going to begin shape type. And I guess this corresponds, because I took a graphics course. As a matter of fact, I just finished a graphics exam, my graphics finals, and my graphics class was all about OpenGL. So I guess you need to call shape.begin or shape.end before starting a new shape, because the way you declared the points. So GL begin, GL points, GL line loop, or something like that, or GL quad, or GL rectangles. But then if you're starting another one, you first need to do you need to flush it? Well, you need to end it. Yeah, you need to end it, so yeah, that's why, I guess. Just my guess. I'm not really sure. I don't know. I'm not smart. So again, same protocol. We're going to draw a filled circle. The center is going to be at camera.rect.x plus 50, so a little bit to the right from the left of our screen. And then it's going to be a top left, so camera.rect.y plus camera.rect.height. Come on, Vandolph. Or you can just do that. Sure. Yeah, I extracted the point, so x equal to 50 is going to be somewhere right over here, and y equal to 350 is going to be somewhere right over there. And now what we're going to do is draw a circle, a filled black circle, like that, like so, with the center being right over there. So that, right there. That should be our output. Do the same thing over here, and do the same thing for the bottom left. Let's say a radius of 100. Right, come on, 100 is good enough. Now we're going to do the same thing for the top right circle, except the x component is going to be different. Then shape.end. So yeah, that's about right, 430. Because if you add, why was it 430? I don't even know. But trust me guys, this works. So yeah. Oh, it's 430, the top right, because we want it to be symmetric. For the left, we started at 50, but what is our width? What is our camera width? Our camera width was 480, so 480 minus 50 is 430. So, just had to perform some simple arithmetic. And again, we can sort of treat this as absolute positioning, and it doesn't matter because it's gonna work. Because we're doing it the way we're doing it now with the combined projection matrix. And now I just deleted that. I deleted the variable that I created. I mean, I might as well just so that I did it so that we could, it's cleaner. The class looks cleaner without it. So I'm a little bit OCD like that, Plus only one multiplication, so it shouldn't hurt that much. Alright, init arrays. We're gonna add that to our drawables list. Right? HUD. Update the HUD, add it to our updatable list. Also add it to our drawables list. Add the HUD, because remember the HUD implemented updatables, drawable, and disposable. And this is so cool because this is it. This is the only place that you need to change anything. So that's it. You don't need to change anything else. You're done. You are now updating the HUD. You're now drawing the HUD, and you're now disposing the HUD. So that's it. Just added 3 lines of code because we're using interfaces. I mean, this isn't the only use for interfaces, but I like to use it this way. It's the beginner way of using it, I guess. I mean, whatever I do is just the beginner. Yay! And I guess for the bottom left circle is a little too big, the radius. For the bottom left circle is a little too big, so we should change that. So yeah, I'm just explaining how everything works. Pretty sure it's pretty self-explanatory, hopefully. I hope I'm not being too presumptuous. Is that even a word? Presumptuous? Whatever. Yeah, the top bottom left circle is definitely way too big. Come on, Vandolph, change it. Oh, what am I doing? Right, I was wondering why the background was not being drawn. It was probably because we added the HUD in our drawables list, and since it's in our drawables list, the batch.end is not called until all of the things in the list is drawn. The draw method call is called. So, I mean, my guess is that it interferes with batch.end, because before batch.end, if we put our HUD in the drawables list, this method is going to get called, and shape, shape.begin and shape.end, and then shape.begin. Shape.begin might be interfering with batch.end. So what we're going to do is we're just going to remove HUD from our drawables list and draw it separately after batch.end, and I think this should work. So yeah, draw separately since this conflicts with the sprite batch in use. And I misspelled this conflicts over there. And that works! Yay! Awesome! Great! We are such noobs. That looks pretty good. right? Looks pretty similar. We don't have the textures yet, but we're gonna put it there, don't worry. In due time, in due time. Yeah, it's too big, Vandolph. Make it smaller. That's what she said to me last night. It was way too big. Couldn't fit. Anyways, change that to 100 instead of 130. And with this, it should be good. Alright, and thankfully it is now over. My nightmare's over. Thank you guys, and follow me in the next video where there's going to be a lot more programming. We're going to make a lot of progress in the next video.